Lesson on notation when it comes to isotopes. So I'm looking at a piece of paper that is going to be in your hands pretty soon, whether you can pick it up or it gets dropped off. At the top it says isotopes. It has letters and some drawings on it. If you want to reference that as we discuss some of this, and then also make sure you have your periodic table out, because this will make a lot more sense if you're using your periodic table. So once again, we're talking about isotopes. And the elements, remember there are 118 elements on our periodic table currently. And we distinguish elements typically by their number of protons. So elements are defined by their number of protons. Once again, elements are defined by their number of protons. Their number of protons is also called an atomic number. We learned that yesterday. The number of protons is also called your atomic number. Then we learned yesterday about isotopes. Isotopes are defined by the number of neutrons. Isotopes are defined by number of neutrons. So isotopes are basically a different version of the same element. It's still the same element. It still has the same number of protons no matter what. An element will never change its number of protons, but it can change its number of neutrons. When it changes its number of neutrons, that is called an isotope. So isotopes are defined by their number of neutrons. And today we'll learn a little bit about something called an ion, I-O-N, ion. An ion is defined by the number of electrons it has. Ions are defined by the number of electrons. So we have elements, which are defined by protons. We have isotopes, which are defined by neutrons, and then ions, which are defined by electrons. Just as a reminder, protons have a positive charge, neutrons have a neutral or no charge, and electrons carry a negative charge. So our isotope notation, this is from yesterday, it's just a reminder, this is how you notate them. This is the diagram you use. You use your chemical symbol, your total mass, and then your atomic number. Total mass, atomic number, or number of protons. These are the two simple formulas you use for that. If you want to find your mass, you're going to add your protons and your neutrons. If you want to find your number of neutrons, you're going to subtract your number of protons from your total mass. So that's from yesterday. You need to go back and watch that video. You can do so. That's just a reminder. This is going to lead into this. These are examples, once again, the same ones from yesterday about your notation. We have boron, we have nitrogen, and we have selenium. We know each one has a atomic number or the number of protons, and they're all at the bottom. So boron has 5 protons, nitrogen has 7, selenium has 34. We know where they each go. We also know the top number is the atomic mass, your total when you add your number of protons and neutrons. So you have 10 as your mass, 15 as your mass, 79 as your mass. So we've discussed this already and what it means. So look at your middle row now. These are the same elements, the same masses, the same protons, but you'll notice that they have another number on the right side. That is a charge. Most elements can carry a charge, and that is defined by the number of electrons it has. So when you notice these charges, you're going to deal with electrons. Let me also say this. This is very important for you to understand. If your element atom is neutral, which means it does not have a charge. You see how none of these have a charge? You're going to assume that your number of protons and electrons is the same. So in these 3 instances, you have 5 protons and you also have 5 electrons because your charges are being balanced. Also in the middle one, you have 7 protons, you also have 7 electrons. You have 34 protons in selenium, you also have 34 electrons if there is no charge. Because of that, I want you to remember, please assume that protons and electrons, their number equal each other unless there is a charge. So remember when we were discussing this in class and we said, what's the atomic number of hydrogen? And you would say 1, and it has how many protons? 1. How many electrons? 1. That's because it is neutral. If it carries a charge, that's what changes. So protons and electrons equal each other unless you see a charge. In the middle ones, you do see a charge. You see a charge of -3, +2, +1. Sometimes you'll see the positive and the negative after the number or before. It's the same thing. Some people write it differently. You can put your charge either before or after as long as you see it in that location. So this boron carries a charge of -3 in this problem. Nitrogen carries a charge of +2 in this problem. Selenium carries a charge of positive 1 in this problem. Notice how your protons and your mass are all the same as the previous one. We're just going to do some simple math. So you'll notice I wrote it up here. You're going to see some problems on your worksheet where it asks you how many protons, how many neutrons, how many electrons. This is how you would write it out when it asks. So let's look at this problem. Boron, as we know, carries 5 protons. You see 5 protons at the top. Because you're going to figure out how many neutrons, remember neutrons is your mass minus your protons. So I'm going to subtract top and bottom. 10 minus 5 is 5. I have 5 neutrons. Notice how 5 plus 5 gives me a total of 10 for my mass. So once again, 5 plus 5 is 10. That's your total mass. Then the last thing we're going to learn about this is something new, is how many electrons are there in this particular notation. So you're going to see, because you have 5 protons but your charge is of -3, that means that because every electron carries a charge of a -1 and you have 3 of them, you're essentially going to add that. You're going to do the opposite. So what you're going to do is you're going to add 5 plus 3. 5 plus 3, that gives me 8 electrons. 8 electrons. So you're essentially going to do the opposite of what the actual number is telling you, or the symbol. So once again, you're going to have -3, so you're going to add 5 plus 3, that gives me 8. Because remember, if you have 8, which is negative, -8 plus 5 gives me a charge of -3. So if you want to double check your work and go backwards, remember every electron carries a charge of -1. You have 8 of them, so that's -8. -8 plus your +5 from your protons gives you a charge of -3. And let's move on to the second one. Same scenario. You have nitrogen. This is a charge of +2. You have 7 protons. 7 protons. You have a total mass of 15, which means that you have 8 neutrons, because 15 minus 7 is 8. You have 8 neutrons. Remember the formula, neutrons is mass minus your number of protons. 7 plus 8 gives me 15. That's my total mass once again. How many electrons do I have? If your charge is +2, you're going to subtract that from your protons. 7 minus 2 is 5. 7 minus 2 is 5. That is how I figure out and calculate how many electrons do I have. You want to double check your work? Remember, each electron carries a charge of -1. So -5 plus +7 is going to give me +2. That's where my charge comes from. So -5 plus +7 gives me a charge of +2. Let's look at our last example. Selenium, once again, you have 34 protons. 34 protons. Your total mass is 79. So you're going to subtract 79 minus 34. That's going to give me 45. 45 plus 34, once again, is going to give me 79. That's my total mass. So you're double checking your work. 34 protons, 45 neutrons. Then, how many electrons do I have? If my charge is +1, I'm going to subtract the 1 from 34, which is going to give me 33 electrons. You want to double check your work? Remember, every electron carries a charge of -1. So you have -33 plus 34 is going to give me a charge of +1. So in order to calculate my number of electrons when you have a notation, you're simply going to do the opposite of what the charge is telling you. So if it's -3, I'm going to add it. If it's +2, I'm going to subtract it. If it's +1, I'm going to subtract it once again. Some of these numbers may be larger in some of the problems. It's the same rule that you have to follow. Double check your work. Every electron carries a charge of -1. So turn it into a negative, add it to your positive. It should give you the charge that you have up there. This is ion notation. So now you know how to calculate your total mass, your number of protons, your number of neutrons, and your number of electrons. Let me recap really quick. These are isotopes. These are elements, different versions of them based on the number of neutrons. These are ions. Once again, this is a notation. Ions are defined by the number of electrons. The number of electrons and the number of neutrons does not change which element you have. What changes your number or your name of your element is how many protons you have, once again. So 5 will always be boron, 7 will always be nitrogen, 34 will always be selenium, and so forth. What can change is your number of neutrons and your number of electrons. When they change, if your number of neutron changes, that is called an isotope. If your number of electron changes, that is an ion. We need to understand ions fully so we can understand how compounds work and how elements are combined together into multiple compounds. So these are isotopes based on neutrons. These are ions based on electrons. As you can see, you can have the isotopes and the ions in the same problem. This is based on electrons and this is based on neutrons. Once again, this is a follow-up of the video from yesterday, so make sure you watch both of them from yesterday and the one from today. So in the problems, when you see this, you should be able to calculate protons, neutrons, and electrons based on simple math. Remember, if there is no charge, it's safe to assume your protons and your electrons are the same. They're equal because there is no charge. If you have 5 positive, 5 negative, that gives you 0. Therefore, you don't have a charge. 7 positive, 7 negative, you have a charge of 0, and so forth. Once again, isotopes, ions. Isotopes based on neutrons,